Hello everyone and welcome to your next lesson for web design and development, and we're back to the theory part for design. So your starter, normal, please pop these answers onto your Satchel 1 as a comment please. What do the following stand for? JPEG, GIF and PNG. I think I give it away later, but you pop that in the starter anyway. So we're going to look at file formats today, and there are two types of file format. There's a standard file format and a native file format. Now the standard file format is a file format that can be used by all platforms and packages, and it's portable. Okay, so it can be used, you could create it at home, transfer it into school, and we would still be able to read it, no problem. Doesn't matter what application or package or computer device you've used at home. Or there's a native file format, and it is unique to the proprietary application, and it might not be portable to another package. For example, a .doc is specific to Microsoft Word, and .pages is specific to Apple Mac Pages word processor package. Now, you won't be expected to answer any questions about native file formats because they're no good, but you will need to know all about standard file formats for your National 5 Computing Science course. So, first of all, text. Two main standard file formats for text, .text and .rtf. The .text file only saves the actual words and the paragraphing. Very simple, like a notepad file, simple text editor. But an RTF file also saves all of the formatting information in your word process document, like the fonts, the sizes, the styles, and RTF stands for Rich Text Format. Okay? Now, graphics, file formats. A bitmapped graphic. Now, all graphics will be displayed on a web page will be bitmapped graphics. And there are three main standard file formats for bitmap graphics: JPEG, GIF and PNG. And if I was to say, do you know what these stand for? I'd like to think that you already do, and you've already sent your comment, please. Maybe you haven't. Anyway, we'll look at the bitmap first. So, images that are captured by digital cameras or scanners and displayed in a web page are all bitmaps. And graphics stored as bitmaps require large amounts of storage. A bitmap graphic is stored as a grid of pixels, and each pixel in a bitmap is represented by a binary number. That is a perfect SQA answer. Memorize it. For example, a simple black and white image has got a color depth of 1. That means you only need 1 bit to represent the colour, because we can say it's either a 1 if it's black or a 0 if it's white. Simple as that. Colour depth of 1. We only need 1 bit to show whether it's black or white, each pixel. However, we can have also colour graphics, but they need much more backing storage, because you need more bits per pixel to store the colours. So for example, a 256 colour image, so a GIF which has got up to 256 different colours, will require 8 bits per pixel to store them. That is a colour depth of 8 bits per pixel. But you could have a JPEG, and that requires 24 bits per pixel to store them. It's got a colour depth of 24. Okay, that's a lot of room. For each pixel, you're going to need 3 bytes of storage. So here's a little just sort of example of that. Coloured bit depths. Now, sometimes it's known as colour depth, sometimes it's known as bit depth. It means exactly the same thing. You could have 8 bits for each pixel. And if you do the sum 2 to the power of 8, that will give you the answer 256. And that's the number of different colours you can have. And that is used for the standard file format GIF. If it was 16 bits per pixel, that would be 2 to the power of 16, which is 65,536. There's no standard file format that actually uses that. It's just here for illustrative purposes. But you might have 24 bits per pixel. And if you did your sum on your calculator, 2 to the power of 24, you would come up with a number 16,777,216. And that's what's used for JPEG and PNG. It's something called true colour. I'll come back to that. So, massive amount of storage. We need to reduce the file size, and there's a number of ways that we can reduce the file size of a bitmap. And this is the web design unit. So remember, it's because we want the pictures to appear on our web pages quickly. You don't want somebody sitting waiting for a picture to load, or they'll get bored and they will leave your web page. So there's some ways we can reduce the file size. First of all, we could use compression. Now this can either be lossy or lossless. So lossy compression or lossless compression. I'll explain that a bit more in a minute. We could also decrease the resolution. That means reducing the number of pixels in the graphic. Okay, but that also reduces the quality and it'll make it look quite blocky. I can show you that in a picture in a second. Third way that we could reduce the file size is by decreasing the color depth. And that will reduce the number of colors that we use in the graphic, but that will also reduce the quality. It won't look nearly as good. So here's an example if we decrease the resolution. Here's our original. Remember, what we'll do now is we will have fewer pixels. So as you can see, there's fewer pixels. Each pixel's been given its own color, but it just looks rubbish, okay? Really, really, really bad. That's a low resolution, far fewer pixels in the picture. High resolution is like your high def for your TV, really, really, really sharp because there's lots and lots and lots and lots of pixels making up the picture. If we reduce the color depth, here's our original picture. And if we're not using nearly as many colours, then it just comes to, well, not a realistic and not a very pretty colour. Okay. So if we look at compression as far as a JPEG is concerned, this uses something called lossy compression. That means that the parts of the image are permanently lost. You're reducing your file size by getting rid of parts of the image. So lossy compression cuts out parts of the image which are not noticeable to the human eye. And the new file is called a JPEG, Joint Photographic Experts Group. And the higher the level of compression that you use in a JPEG, the more detail is lost, but your storage space is reduced, okay? But the compression can make the image look a little bit odd, and if you zoom in, you'll be able to see what's known as artifacts. Now, JPEGs are used to store photos, natural, real-life images with many different shadings, lots and lots of different colours. If you remember, 60,777,216 different colours. Oh, just said that. And that's called true colour, because true colour, they have kind of proven that the human eye and brain can discern round about 16 million different shades and colours. So that's why JPEGs, 24 bits per pixel is known as true colour. Now here's the artifacts I was talking about. This image has been compressed, and you get these kind of strange things. Like in particular, the funny thing about a JPEG is when you've got a big area of the same colour, it does some very weird things to it. Now I'm not sure what you'll be able to see in the video, but there's some very odd looking parts, and that's all to do with the artifacts that have just come through this method of compression. They wouldn't all be really bad examples. This is zoomed right in. Now let's look at the compression for a GIF. Now you can get smaller file sizes if you use the graphics interchange format. And this uses lossless compression. Lossless, so we've not lost anything. The original quality in the image isn't lost permanently. You reduce it, you compress it so you can upload the image, but the quality in the original image will be what you will see. And this uses an 8-bit colour depth, 2 to the power of 8, 256 different colours. And we use it for animations, drawings, logos, images with large blocks of single colours. Now, it's used for images, so don't get distracted by animated GIFs. Apologies for giving you one to distract you, but we're talking about images. But we can use it for little animated GIFs as well. The good thing about a GIF image is that it actually supports a transparent value for pixels. So one of those 256 colours is actually fully transparent. So that means that you can actually get rid of the background of an image. Okay, so that's quite important for a GIF. Now we'll look at PNG. So that's another way of compressing the bitmap, is using another lossless compression technique. In other words, we're not going to lose it permanently, and that's PNG. Now it uses complex mathematical formulae to reduce the file size without reducing the resolution or the colour depth. And portable network graphics are an improvement in GIF files because they can have many more colours. Their colour depth is much higher. Remember, the GIF was only 256 different colours. But we could go up to 24 bits, which remember is 60,777,216 different colours. Or we could go up to 2 to the power of 48 colours. But that's just ridiculous. The human eye can't discern that many different colours, so there's actually no point. Okay? Now, PNGs are used to store graphics for web pages, but so are JPEGs and so are GIFs, because that's what we're on. We're in the web unit, so we're talking about for web pages. But a really good thing about PNGs is that they can use different levels of transparency. So it doesn't just have, completely transparent or not at all. You can have lots and lots of different shading. So you can have different levels of the image showing through in the background through your image. Okay, so fading from opaque, you can't see through it at all, to fully transparent. Lots and lots of different levels. Now this is a summary, a comparison of all of the bitmap graphics. Okay, now you don't need to know all of the information. In particular, please ignore the information in red. But we've got JPEG. It's used for real life images and photographs. Lots and lots of different colours. So, if it was a picture of a forest, lots and lots of different shades of green, the shadow, everything. A GIF is used for images that have got blocks of the same colour. So like a cartoon image or a logo, and it can be used for simple animations. The compression, JPEG is lossy, permanently losing part of the image, but GIF and PNG are both lossless. You do not need to know how they compress. Please ignore that. Well beyond the scope of National 5. The quality, a JPEG quality is high. PNG is very high. GIF, very, very high for cartoons, but rubbish for photos. Okay, because it's only got 256 different colours. So the JPEG has got the colour depth of 24 bits, 16,777,216 different colours. Medium file size. The GIF is only got 8 bits, so it can only display 256 different colours, so it's got quite a small file size. And then the PNG, 24 bits, same number of colours as a JPEG, and quite a big file size. Okay, so they've all got benefits or advantages and disadvantages. So the next thing that I want you to do is go and complete this task sheet. Now it's task sheet number 8 and it's called media types. I'll just quickly show you that. It's quite a simple one. You just go into the BBC website, choose a page and look ahead to the questions before you choose the page. Read the questions first because you need to identify a page that includes as many examples of the different media as possible. You then copy and paste the URL of your page you found into the box, and then you go ahead and you find examples. Now there's 2 examples that you've got to find of each of these different types of media, and then you've got to do some counting for me at the bottom. Okay, back to our PowerPoint. Okay, so now we've looked at graphics, we've looked at text, now we're going to look at sound. Now audio is stored by taking a digital sample of a sound at regular intervals. That's known as the sampling rate. The sampling rate is how often the sound is captured or recorded per second. Sound is an analog signal, and what we're trying to do is digitize it to store it in the computer. Okay, so what we're going to do is we're going to take samples, little slices of the sound. Now, the higher the sampling rate, so the more samples you can take per second, the more samples you can take per second of the sound, the better the quality. However, if you're taking a higher sample rate, then it's going to be a much bigger file size. Now, there are 2 different standard file formats for audio files. There's WAV or WAV and MP3. So we'll look at the first of those. Now this is the WAV file or WAV file, and this comes from the file extension of a waveform audio file format originally developed in 1991 for use with Windows systems. And it works by taking an audio signal and converting it to binary data. To do this, a device called an analog to digital converter takes snapshot slices thousands of times per second. For example, CD quality audio records at 44.1 kilohertz. Now, kilo means 1,000, hertz means times per second, so that means it records 44,100 slices per second. That means that to actually achieve the sound that would be equivalent to you sitting or standing at the concert, listening to music, you need to get 44,100 different little digital samples stitched back together to get it to reflect natural sound. Mind-boggling. And it means that it creates very, very large files because you've got so many samples per second. If you could lower the sample rate, and that would reduce the size of the file, but it would absolutely reduce the quality and you would notice it. Okay. Now the other type of audio file is an MP3, and that comes from Moving Picture Experts Group Layer 3, and it uses a lossy compression technique which reduces the file size a lot and the quality a little. Okay. Now, lossy compression technique means that it is lost permanently. Okay, you've lost it for good. Now, the loss in quality is very small, but the file size can be 1/10 of the size of the original WAV file. Therefore, it's used for storing and transferring sound files on the internet for downloads. And of course, it is used on web pages. Okay, now you don't realize this, but the MP3 tunes that you guys listen to are actually poorer quality, okay, than what people of my generation are used to listening to. Anyway, how do we get this compression? We're getting this down to 1/10 of the original size. So how do we do it? First of all, MP3 compression knows that there are certain frequencies that the human ear can't hear. So it gets rid of this data. So above the range of our hearing and below the range of our hearing, it just gets rid of it, just discards that sound because there's no point in storing it. Also, MP3 compression realizes that there are sounds that, if they're loud, then they will mask or hide certain quieter sounds. So it gets rid of the quieter background sound, okay, because we're not hearing it anyway. So it's not storing that, so it's reducing its size. And also, it uses the fact that the human ear will hear some frequencies better than others. Now here's a comparison of them. The WAV is lossless compression. MP3 is lossy, uses these different techniques I've just mentioned. The wave quality is high, good, would fool the human ear into thinking it was hearing real sound. MP3 is good quality, not as good as wave, but the file size, big difference, a large file size for a wave, completely impractical for, you know, on your phone, your smartphone, MP3 player, anything like that. And streaming, and obviously in your web page. Remember, this is the web unit. And the MP3 file size, very small. It's actually 1/10 of the size of the original WAV file. Therefore, it's great for portability, great for streaming, and great for planting onto your web page. Small file size. Right, now we've got the file format for video. And video files are made up of lots of still images shown quickly, one after the other, to fool the human brain into giving it the illusion of movement. Okay, when you're watching TV, it's actually showing you 25 different little pictures per second to fool you into thinking you're seeing movement. I think it's extraordinary that you only need to see 25 different pictures to think you're seeing movement, but you need to hear 44,100 different slices of sound to hear what sounds like natural sound. But that's just me. Anyway, video files end up being really, really big, and that means that they take up lots and lots of storage space because you need to take into account the length of the clip, the frame rate, which could be 25 frames per second, the color depth. Now, if it's a movie, you'll be wanting it to be the 16,777,216 different colors, so it'll be 24 bits per pixel. And then the resolution. Now you know that the high resolution, there's lots and lots and lots of pixels to get that sharper image. So the higher the resolution, the more pixels, therefore the more storage space. Okay, so it's all going to affect the file size. There are two common standard file formats, AVI or AVI, Audio Video Interleave, and MP4, Moving Pictures Expert Group Layer 4. And they also use compression techniques to reduce their size. And what they do, you've got the factors which will affect the file size and quality of a video file are, it's resolution. So the higher the resolution, the bigger the file size, but the better the quality. The higher the color depth, the bigger the file size, the better the quality. The higher the frame rate, the bigger the file size, and the better the quality. Okay. So compression, I've mentioned it lots of times. What is compression? Compression is a method of reducing the amount of storage space needed to save a file. So compressing something means squashing it together so that it will take up less room. You've got lossless compression and you've got lossy compression. Now lossless compression is like when you compress something down, you put it into one of these pockets that reduces all the air, you've compressed it right down. When you take it out, you let the air in, I'm talking about a fluffy jumper, it puffs up again to its original size. Lossless, you've not lost anything of the original. But lossy, you're compressing it, you're making it smaller by getting rid of parts of it permanently. Okay, now the advantages of compression, remember we're talking about websites. A file will take less time to upload, download, transfer if it was on a web page. Okay, so getting that picture, that sound file, that movie onto your web page, smaller it is, the quicker it will appear on your web page. Secondary to that is the idea that you could actually store more images, movies and music. If they've got smaller file sizes requiring less space, then you can store more of them. But be very careful about this question. Make sure what direction it's asking it for, because it's going to be about this idea of loading up on a web page. The disadvantages of compression: compressing large files, it can take a lot of time. And repeatedly sort of compressing, uncompressing, compressing, uncompressing files will damage the quality eventually of the video or the audio or the image. Okay, so now you've got another task. It's your second task, don't worry, and your last. Task sheet 8, all about file formats. Just show you what that one looks like. Okay, quite simple. Fill in the correct standard file format. So that's going to be dot something. .rtf, .avi, .jpeg, .gif. Okay, you've got to identify the right standard file format to fill in here to go with the scenarios that are given here. Okay, not too many of them, 20 for you. Okay, that's that bit. And then back to the PowerPoint. One more slide, your summary. So your task for me for this lesson at the end of the week: send the answers to the starter. I've told you them all now, so if you didn't do it before you got to the end of the video, you can certainly do it now. Comment in Satchel 1, and you've got 2 task sheets. Task sheet 8, all about media types, and task sheet 9, all about file formats. Okay guys, thank you very much. Good luck. Take care. Bye bye.